Hi everybody, in this video we're going to look at some properties of exponents, and there's actually quite a lot of properties of exponents, and they can be used in different ways. So the ones that we're going to focus on in this video are going to be some of the beginning properties, things like the product and the power rule, and again we'll talk about what those are in a second. And they're nice because they do help us a lot with things like multiplying polynomials. So we're going to look at these beginning rules in this video. Now, there's lots of different rules for the properties of exponents, so there's quite a few different properties that we can talk about. So like I said, in this particular video, I'm going to focus on rules that are called the product and power rules. So we're not going to do every single property of exponents in this one video. We'll start with a couple, and then we can do more later. All right, so our first rule is the product rule. Or product property, whatever you want to call it. So the product rule says, first of all, let m and n be positive integers here, and a real number. Then when we're multiplying two different exponent expressions together with the same base, the shortcut is to just add the exponent. Now, I will say too that if m and n are actually not positive, even if they're negative or fractions or anything else, this rule actually still holds. But you'll see that we'll tend to focus on the more basic examples to start. So here, notice that we have the same base. Okay. So when multiplying exponential expressions, we're going to add the exponents. And again, this is assuming we have the same base here. So let me show you some examples, and it's not as bad as it sounds. So x squared times x to the third. Notice that they have the same base. They're both x's, right? So all you have to do is do 2 plus 3, and the answer is x to the fifth. That's it. And this should make sense, right? Because x squared is x times x, and x cubed is x times x times x. So if you think about it, you have 1, 2, 3, 4, 5 x's all together, which is where the x to the fifth comes from. So these rules for exponents are shortcuts. They're not changing the actual definition of anything, so they still form in line with the definition. If I were to actually break this down and think about what an exponent means, then I could get the same answer that way, right? By counting up the number of x's I have. But this is just a shortcut, so that's all it is. So let's say I'm multiplying even 3 things. If they all have the same base, that's key here, same base, that I can just add. Now, if you don't have an exponent, you want to be careful. There is always a 1 there. So it's going to be y to the 1 plus 2 plus 4. So y to the 7th. And this even works if our numbers are part of the exponent expression. So let's say I had 2 to the 5th times 2 to the 7th. Now these are some pretty big numbers. If you actually wanted to multiply this out, you get a pretty large number here, but let's say I want to leave it as an exponent. Again, I have the same base, which is important. So I just do 5 plus 7 and I get to the 12th. Okay, so it works the same way here. Now I will clarify, let's do a couple more examples here. Let's say you have something a little bit different, like 4x squared times 3x to the 5th power. So I'm taking it up a little bit here. I do see I have those exponents with the matching bases, but notice that I have a 4 and a 3. Those are not the same bases. So what happens here is you have kind of two different ideas in your head. You're going to use the shortcut for the exponent part, but the numbers out front we're just going to multiply as usual. And it's different than this example here because these had exponents with the same base. These are no exponents on the 4 or the 3, and they're different bases. So this becomes 4 times 3, and then the x squared times x to the 5th gets put together. And I can move things around because of the commutative and associative properties of multiplication. So 4 times 3 is 12, and then here 2 plus 5 is 7. Now, of course, if you can do this right in your head, that's absolutely fine. You don't have to rewrite that middle step, but we can. All right, I'm going to kick it up a little bit again here. So notice that I have a few different things going on. I have numbers out front, which don't have exponents. So they're just going to work as usual. And then I have A's and B's. So what we do if we have more than one variable and we're trying to use our shortcut is we match up the variables. So for instance, I'm going to do -2 times 3, right? And then my A's are going to be A squared times A cubed. And then my B's is B to the 5th times, B. So -2 times 3 is -6. And then for the A's here, I have A to the 2 plus 3, which is 5. And don't forget on that B here, there is a 1 there. So this is going to be B to the 5 plus 1, which is B to the 6. So we can extend this rule to really any combination from, so again, this is all multiplication problems. That's the key here. Everything is multiplication. So I can rearrange and just group the same kind of exponents together to use that shortcut. Okay. All right, let's do maybe one more of those before we move on. So I'm multiplying here. I'm actually multiplying two monomials or two polynomials, if you remember your definitions there, but it doesn't matter. So just think about what you have. And let's do this a little bit more mentally. So I see my numbers out front. They don't have exponents, so they're not under the shortcut. They're just regular numbers. 5 times 2 is 10. Now we're going to move over and do our first variable. Now, again, if there's no number, there is one. It's a 1. So I have x and x1 and x2. So I'm going to do x to the 1 plus 2, which is 3. Now I do my y's. So times y to the 2 plus 7. So y to the 9th. And then z to the 4 plus 10. So z to the 14. These are all different kinds of bases, and you can't combine them together now. Don't put 3 plus 9 plus 14 together. We are done. So when we multiply, again, that's the key thing. We're multiplying here, and we have exponents. The shortcut is that we can add them. And again, we're not changing any rules here. If you go back to that first example that I sort of did with you guys, where I wrote out each piece, right? I'm not changing any rules. I'm still using what exponents are, what they mean. I'm just providing you a shortcut so you can do it quicker. Okay, so that's called the product rule. And again, products have to do with multiplication. So when we're multiplying. Okay, let's see. Okay. So next, we're going to look at the power rule or power property. Again, if m and n are positive integers and a is a real number, then a to the m to the n is the same thing as a to the m times n. So again, here I'm saying m and n are positive integers, but they really work for anything. Even if m and n were fractions or negative, this rule actually still holds. So let's see what this one says here. So notice this one is different. You only have one base, but two exponents this time. Now, notice how that is different than the last rule. So let me bring the last rule up. So the last rule, look at, you had two bases, right? A and A, they were written twice. They were the same. Here, you have only one base and the exponent is sort of doubled on itself. So what's going to happen here is that when we have a power to a power, so an exponent to an exponent, we multiply the powers together. And that is, again, a shortcut. Doesn't mean that we always have to do it that way, but it's a shortcut. So it's going to save us a lot of time. All right, let's do some examples here. So notice I have one base, it's just x, and then I have it squared and to the third power. So basically what you're going to do is you're going to take those two exponents and you're going to multiply them together. So x to the 2 times 3 is equal to x to the 6th power. Now, I just want to show you why this still works. So think about this, right? If you have x squared to the third power, well, that would mean to take this x squared and to do it 3 times, right? Right, so 1, 2, 3. But each of those x squareds is x times x. So look at how many x's you actually have in this problem. You have 1, 2, 3, 4, 5, 6. So that's how the 6 comes into play here. We're not changing the fundamentals of what it means to be an exponent. I'm just providing you a shortcut, a faster way to do it. Okay, let's do another example. So here, y to the 8th to the 4th. So again, I see I have those double exponents there. I'm going to multiply. So I do 8 times 4, which is 32. I'm going to make a note to be careful and to not mix up these rules, which is really easy to do. So for instance, right, let's say I have x squared times x cubed versus x squared cubed. Now I've done both of these problems already, so you should know the answer. But think about the rules here. So we're multiplying these together and I have two bases. So what it says to do is to add the exponents, whereas something like this says to multiply the exponents, right? So you're going to get different answers the vast majority of the time. You need to be really, really, really careful. And this is something that students mix up all the time. And if you're looking at it now, you may be saying, yeah, but this is easy, right? I can do this. It's only 2 rules. And it's easy now, but it gets tough once we start getting to more complicated problems that have more steps. It's easy to mix them up as you start adding on more rules and more steps. So you really want to kind of keep these separate in your mind. If you have to, make a little note card for yourself. Put some examples on there, write these rules on there so that when you do an example, it kind of will jog your memory on how to solve it. So let's do an example that's like a little bit harder, you can see. All right, so here is a little bit more complicated. I have a to the third to the fourth power times a to the second to the seventh power. So first of all, I do see I have these kind of double exponents here, right? So when I see something like that, I am going to go ahead and multiply those. So this becomes 3 times 4, which is 12. So I have a to the 12th. And this is 2 times 7, which is 14. And that multiplication symbol comes in between. Now my double powers are all gone, and here I have a to the 12th times a to the 14th. So this is now that product rule. So this is the power rule. This is now the product rule. So we're going to do a to the 12 plus 14, which is a to the, 26th power. So you just want to be careful. So when we're using the power rule, when you have these double exponents together, they're really kind of like touching almost, then you're multiplying them. Here, each exponent is pretty far apart. It has its own base. So we're going to go back to adding the exponents. Okay, so this is what I'm saying. It gets a little bit tricky once we get a little bit more complicated. So you really want to get comfortable here. All right. And there's one more rule I want to go through in this particular video. And that is the power of a product rule or property. All right, so here is the last rule for right now. It says, if n is a positive integer and a and b are real numbers, then if you're multiplying two things and you're raising it to the nth power, you actually can go ahead and distribute that inside here so that each of those bases gets its own power of n. And actually, if n is negative or a fraction, either, the rule still works. So it doesn't have to necessarily be positive, but that rule will still work, okay? So I do want to make a really important note here, again, to be careful. Because we cannot do this with adding or subtracting. For instance, a plus b to the nth power is not a to the nth plus b to the nth. And a minus b to the nth power is not a to the nth minus b to the nth. Okay, so this rule doesn't hold if there's addition or subtraction. It only holds for multiplication, and then we'll also see for division as well. So we can distribute that n in, but it doesn't work in all cases. It is very specific to multiplication and then also to division, but it is not true for adding and subtracting. So you do want to be really, really careful there, because that's something that a very common mistake that people make. So let's say I have something like simplify 5t squared. So again, I have parentheses, I have no addition or subtraction. So what I can do is I can take that square and I can distribute it to both bases. So this becomes 5 squared times t squared. Now, typically if a number is pretty small or easy to simplify, then you should do it. So 5 squared is just 25. So this is 25t squared. Okay. If this was like 5 to the 10th power, that's a really large number. We typically leave it. But if it's a reasonable thing for you to multiply out, then you should probably get used to simplifying that if you can. So 25t squared. Let's do another example here. I'm going to stick with squares for a second. So same thing here. Notice I have 1, 2, 3 parts inside my parentheses. I don't have any addition subtraction. So we are going to go ahead and distribute. I am going to warn you to be really careful. If you have a negative inside the parentheses, when you distribute, that base is -4, not 4. So it's going to be -4 squared like that times a. Now here, I don't have anything, so I can just distribute that 2. But in the last case here, I have b to the 3rd squared. Okay, so I'm going to be really careful there because I don't just have a b, I have b cubed. So it's b cubed squared. And now I'm going to start simplifying. So here, -4 times -4 is positive 16. So 16. A squared is just a squared. But now I have to start using some of my rules, right? So when I have this double exponent here, I can go ahead and multiply. So this becomes b to the 6th power. Okay, so again, you can see it starts getting a little bit more complicated as we start combining things like negatives here we're watching out for, and now we're also multiplying. So we have to be really careful. All right, I'm going to do, I think, just 2 more here. Let's do a couple more. Again, we're going to simplify. So I have 2x to the 5th, y to the 4th, all to the 3rd power. Again, I don't have any pluses or minuses. It's just multiplication. So I can distribute that 3 to each part here. And I'm going to be careful. So I don't have any negatives. So this is just 2 to the 3rd. Now here I have x to the 5th to the 3rd. And then here I have y to the 4th to the 3rd. Now you don't really need these extra multiplication symbols. I just find it easier just to spread my work out a little bit, so I'm staying neater. So here, 2 to the 3rd, well, that would be 2 times 2 times 2, which is 8. And here I have that double exponent, so I'm going to go ahead and multiply, and I'm going to do it again here. So I have x to the 15, and then y to the 12th. So my final answer is 8x 15, y 12. And again, if there's no symbols in between, it's always implied multiplication. So we don't have to write those extra symbols in. All right, and let's do one more again. I'm going to kick it up a little bit here. So here I have 2 sets of parentheses. There is no symbol in between. So if there's no symbol in between, it does imply multiplication in between. Okay. So what I'm going to do is I'm going to kind of think about PEMDAS a little bit, and I'm going to do each set of exponents first separately, right? So I kind of need to clean up each set of parentheses first. Now I know there's something to do on the inside, but I can definitely distribute those exponents throughout. So I'm going to do that. So I'm going to do this one first. And then over here, I'll do the 5. Now we're careful, there's 3 bases in here, right? So make sure those exponents go to every single part. So for the first part, I end up with 3 to the 4th times y to the 4th times z squared to the 4th. And then for the other one, we're just going to put a big multiplication symbol in between just to kind of separate my 2 parts. 2 to the 5th times y cubed to the 5th times z to the 5th to the 5th. Now I'm going to keep cleaning up. So I'm going to do these double exponents first. And remember, we're going to multiply there, right? So let's see, I have 3 to the 4th, and this becomes y to the 4 times 4 is 16. And 2 times 4 is going to be 8. Leave this to the 5th for a second. And then here, 3 times 5 is 15. And then this was a 5. 5 times 5 is 25. All right, I'm going to keep simplifying a little bit. Now, 3 to the 4th, that's one that you probably should know, but it's 3 times 3 times 3 times 3. And if you multiply it out, you get 81. And 2 to the 5th is another one. 2 times 2 is 2 times 2 times 2. Even though it's a lot of 2's, it stays relatively small. So you end up with 32 here. So this becomes 81 y to the 16th, z to the 8th, times 32 y to the 15th, z to the 25th. Now, I'm not quite done yet because I still have a lot of stuff going on that can be combined, right? I see y's here and z's here. I see numbers. So what you want to remember now, so right here we were using that power rule, but now I'm going to go back to the product rule. So I have the same base, right? So I'm going to add those exponents. So what I'm going to end up doing here is I'm going to do 81 times 32, right? Put my numbers together. And then I'm going to do y to the 16 plus 15, putting my y's together. And then I'm going to do z to the 8 plus 25, putting my z's together. So when they each have their own base, I add those exponents when we're multiplying. All right, so let's see. This one I'm definitely going to use a calculator for. So go ahead and use your calculator here. You should get 2,592. Now 16 plus 15 is going to give you 31. And then 8 plus 25 is going to give you 33. All right, these exponent problems, as they get more complicated, can take a lot of time. But you just want to take it one step at a time. So for problems like these, I always tell students not to panic too much in the beginning. So when you see something like this, don't just panic, but look at it and just say, what's one thing I can do? And a lot of times you may recognize, oh, I can distribute that 4. So do that first, okay? And then do the other side. And then look at it again and say, okay, what's another thing that I can do? And again, you may recognize like, oh, I see those double exponents. I know what to do with those, right? So when you see a hard problem like this, don't go in thinking, what's the final answer? Go in thinking, okay, what's one thing I know how to do? And you want to take these one step at a time. Okay? So you just do it one thing at a time over and over again, and then eventually you're going to get to that final answer. Okay, so don't get too overwhelmed with these. Take your time. And the more practice you do, the easier they do become. So until you're there, maybe make a little note card for yourself or something to kind of keep these rules on or keep some examples with you as you're going through the work. But like I said, the more you practice, the easier they are going to get.